This is Mr. Beck Does Your Homework. This is AP Physics Homework 3.1 about balanced forces. In balanced forces, we know all the forces in one direction must equal all the forces in the other direction. But this is a great question because I've got a car on an incline, and that's going to present some new situations. It says an 1,100 kilogram car is parked on a 4-degree incline. The acceleration of gravity is 9.8 meters per second squared. Find the force of friction keeping the car from sliding down the incline. Answer in units of newtons. If I draw a picture here, I've got this incline that's 4 degrees. I know that's not to scale. And I've got this car that's parked on the incline. If I were to draw a free body diagram of that car, what I have is gravity straight down. I have a normal force perpendicular to the surface. And I have friction backwards up the hill, because otherwise the thing would slide down the hill. So really, those are my only forces on my free body diagram. But somehow, they're all balanced. Now, I don't want to turn this into x and y and try to find the force of friction horizontally and the force normal horizontally and vertically and try to mess that up. Because what's interesting in a down the ramp sort of problem is I can just set up my axes so that I've got a parallel to the ramp and a perpendicular to the ramp. So what I call this is up the ramp, this is down the ramp, this is into the ramp, pushing into the ramp, and this is going to be pushing out of the ramp. Oops, out of the ramp. So down and up and in and out is how I like to describe these sorts of problems. Now, force of friction is an upward force. It's right up the ramp. That's good. Force of normal is out of the ramp. That's good. So I've got gravity as my monster in this case. Gravity is neither all the way in or all the way down. Gravity is made up of components. So if I take my force of gravity that is straight down, what I can do is take that force and split it into how much is gravity pushing into the ramp and how much is gravity pushing down the ramp. So this is my force of gravity. This is my force of gravity into the ramp, and this is my force of gravity down the ramp. Now, if I pay attention, I see that this 4-degree angle equals this 4-degree angle. So force of gravity down the ramp is opposite that, because here's my right angle in this triangle. So my force of gravity down is going to equal my overall force of gravity, since it's opposite, times the sine of theta. And my force of gravity into the slope, that's this one, is going to equal my overall force of gravity times the cosine of the angle, because this is adjacent and this is opposite. This also should remind you g sine theta was the acceleration down an incline if there wasn't any friction. So now let's look back. Find the force of friction keeping the car from sliding down the incline. Well, let me redraw my free body diagram, but I'm going to use my components this time instead of my gravity itself. So if I use my components, I know that I've got a force of gravity down. I've got friction pointing up. I have my force of gravity in, and I've got my normal force this way. What's neat here is that the friction must equal gravity down, and the normal must equal gravity in, and that's how I'm going to solve this problem. So let's look back. Find the force of friction keeping the car from sliding down the incline. Well, I know that my force of friction must equal my force of gravity down this one. So these two are equal. So g down is Fg sine theta, so my force of friction is going to be my force of gravity times sine theta. It's 1,100 kilograms. So what is Fg? I know that my force of gravity equals the mass of the object times the acceleration of gravity. So this is going to be 1,100 times 9.8, and that's going to give me my force of gravity. Take that, and I want how much of that is down, so my force of friction is going to be my force of gravity times the sine of 4 degrees, which is not going to be a very big number, but it's big enough. So that will give me my force of friction holding the car up the slope.